During an eclipse, the moon slowly passes in front of the sun. Can we determine the size of the moon from this observation? Distance equals rate times time. If we knew the rate of the moon's movement and the time of travel, we can calculate the distance it moved. We start this interesting journey with a calculation that will tell us the rate of speed of the moon. Well, it takes 28 days to go all around the Earth. Let's do everything in minutes. Google tells us that there are 1,400 minutes in a day, so it takes 28 times 1,400 is equal to 40,000 minutes for the moon to go around the Earth. And around the Earth is how far? The circumference is 2 pi r, and radius, the distance to the moon, is 239,000 miles. Cool. So in 48 days, the moon goes 2 pi r equals 2 times 3.14 times 239,000 is equal to 1.5 million miles. This exercise is all about distance equals rate times time, but so rate is equal to distance over time. So the rate is equal to 1.5 million miles divided by 43,000 minutes is equal to 37 miles a minute. So we know that the moon moves 37 miles a minute. The moon gets closer and closer to the sun and the eclipse starts. We find this time in the news. The eclipse will start at 1:09 p.m. The moon moves across the sun, covers it, then moves by. The moon leaves the sun altogether, and again, the news tells us the eclipse ends at 4:23. The whole thing is about 3 hours and 15 minutes. Let's call it 195 minutes. Distance equals rate times time. So the rate is 37 miles a minute times the 195 minutes is equal to 7,200 miles. But this is 3 diameters. So the diameter, according to our assumptions, is 7,200 divided by 3 is equal to 2,400 miles. Google says that the diameter is 2,159 miles. This looks okay to me. Scientists make assumptions all the time, and then based upon those assumptions, make conclusions. That is what we have done. We are really just using the sun for measurement. It is an astonishing coincidence that the moon and the sun are the same size in our sky.